Geothermal geology is a fascinating field that focuses on understanding the Earth's thermal energy and how it can be harnessed for various applications. Here's an overview of the basics of geothermal geology. Geothermal energy. Geothermal energy refers to the heat stored within the Earth's crust, primarily originating from the planet's formation and the decay of radioactive isotopes. This energy can be harnessed and used for electricity generation, heating, cooling, and other direct uses. Geothermal systems. Geothermal energy exists in different forms, but the most common systems are hydrothermal and enhanced geothermal systems, EGS. Hydrothermal systems. These are natural geothermal systems where hot water or steam reservoirs exist in permeable rock formations. The heat is transferred from the deeper regions of the Earth to shallower levels, creating high-temperature geothermal reservoirs. Enhanced geothermal systems, EGS. EGS involves creating artificial reservoirs where the natural permeability might be low. This is done by injecting water into hot rocks to create fractures, enabling the circulation of water and heat exchange. Geothermal gradient. The Earth's temperature increases with depth, and this relationship is known as the geothermal gradient. On average, the geothermal gradient is about 25 to 30 degrees Celsius per kilometer of depth, but it can vary significantly depending on local geology and tectonic activity. Geological settings. Geothermal resources are often associated with tectonic plate boundaries and regions of active volcanism. The most geothermally active areas are found along the Ring of Fire, which encircles the Pacific Ocean and is known for its frequent earthquakes and volcanic eruptions. Geothermal exploration. Geologists and geothermal experts use various methods to explore and assess potential geothermal resources. Techniques include geological mapping, geophysical surveys, e.g., gravity, magnetic, seismic, geochemical analysis, and temperature gradient drilling. Geothermal power plants. Geothermal energy is converted into electricity using different types of power plants. Dry steam power plants. These plants use steam directly from the geothermal reservoir to drive turbines and generate electricity. Flash steam power plants. These plants use high-pressure hot water from the reservoir. The pressure drop causes the water to flash into steam, which is then used to power turbines. Binary cycle power plants. Binary plants transfer the heat from the geothermal fluid to a secondary fluid with a lower boiling point, e.g., isobutane. The secondary fluid vaporizes and drives turbines to produce electricity. Direct geothermal uses. Geothermal energy can also be used directly for heating purposes, such as district heating systems, greenhouses, spa resorts, and even for drying crops and fish farming. Environmental considerations. While geothermal energy is considered a renewable and environmentally friendly energy source, there are some potential environmental concerns. These include the release of gases and trace elements from geothermal fluids and the possibility of inducing seismic activity in certain cases. Global utilization. Geothermal energy is used in more than 80 countries worldwide, with significant geothermal power capacity in countries like the United States, the Philippines, Indonesia, and Mexico. Geothermal geology plays a crucial role in identifying and developing geothermal resources for sustainable energy production and various direct applications, making it an important field of study for addressing our energy needs while reducing greenhouse gas emissions.